So hello everyone, I'm back here with another project. I know it's been a very long time. I've finally finished up with college now, so I have a bit more time to work on stuff. And as you can see here, we have quite an interesting project on our hands. This is a real Castle Castings air raid siren, later model I believe due to the tapered base. So what this video is going to be about is basically what I did to bring it back to life and to restore it. So yeah, as I said, it's been a very long time since I've gone near the YouTube channel, but nonetheless it creeped up over 1,000 subscribers. So I'm very grateful for that. Thank you. So I really hope you enjoy this little video, just showing what was the process to bring this siren back to life and get it going again. And in the near future, you will see some footage of this siren actually running. I'm currently waiting on a bigger VFD inverter to actually run it at full speed, but I have taken it up to about half speed with the inverter I have. So in the near future, I'll release that a video of that as a short. So yeah, we'll get into this now, and I'll just show you what I did to get it going. So here we go. Taking a first look at the siren, you can see that we can see some of the original paint, the original color of this siren. It wasn't the British Navy or battleship grey, as you might think, but it's more of a kind of a teal turquoise color or duck egg blue. So you could just see on the stage there's some remnants of that. So that's what I kind of used to match up the paint, and the closest I could get to that near me anyway, without going as far as getting it professionally matched, was Rust-Oleum's Duck Egg Blue, and I think it actually turned out quite well. I like the colour of it, so you'll see that later on. But yeah, the condition of this siren was fairly poor. As you saw the first picture there, it's completely separated from its base. The motor brackets that hold the base, or the actual siren body to the base, have completely corroded away. So you're going to see a lot of corrosion on this siren. It's quite bad. The corrosion on it was quite bad. You could see one of the nuts there for holding the rotors on. It's quite badly corroded, but that was probably the best nut that was actually on this siren. The rest had completely gone away to nothing, and so much so it actually damaged the threads, which we might see later on. So we'll move on. Uh, I managed, thankfully, despite the appalling condition of all the hardware and bolts in the siren, I managed to get them out through a combination of drilling, cutting slots in them with an angle grinder, then carefully removing them, and then applying a lot of heat to the bolts. But got the stator separated, and you can just see there on the motor flange of the siren there on the ground how much corrosion has built up. Um, Thankfully, I was able to get the rotors off easily enough. And what I actually think has happened was the stators had bulged that much away from the motor flange that they popped the rotors off the shaft a little bit, so the rotors were actually loose. And because those nuts that hold them on had eroded away to nothing, the rotors were actually free to slide off. So that made life a bit easier, because I was a bit worried I wouldn't be able to get the rotors off, but they came off very easily. Um, so you can really see that white kind of powder. That's your aluminium oxide that's formed over the years of moisture getting in between the stator and the motor flange. So yeah, you can really see the extent of the corrosion here and what's actually happened. So what happened here is a thing called galvanic corrosion. The stators of this iron are made of cast aluminium, and the motor flange is made of cast iron. So you have two dissimilar metals. And what happens is when moisture gets between them, the moisture acts as an electrolyte, helps, believe it or not, electricity conduct between them. So it basically turns the thing into a sort of battery. And when it starts doing that, it just starts eating away at the aluminium, turning it into oxide, and it makes so much aluminium oxide. You can see there on the stator how it's completely deformed the metal. So where it bolted to the motor flange, they're the lowest parts because they were clamped to the flange. But then you can see there between each hole, it actually pushes it out completely, and that's why my theory is that it kind of helped nearly push the rotors off the motor shaft. So yeah, it was crazy. I couldn't believe just how much corrosion there was when I took it apart. Um, so yeah, but anyway, so I got it all apart anyway, and I said, right, so the first thing is I will restore the base of it. Start with probably the easiest part because it's just a lump of cast iron, really. Thankfully, the rusted bolts came out after a lot of heat and WD-40. They came out of the base, and that means I was able to start sanding it back. And I used a wire brush, drill-mounted wire brush, to remove the majority of the rust. And then I was able to, if we see here in the next picture, I was able to apply Hammerite crust. That's crust with a K. It's basically a rust converter. It does not entirely sure the chemical process, but it converts the iron oxide into a stable surface, which allows you to paint it. So then, of course, as soon as you put that on, let it dry, and then I applied some anti-rust zinc primer to hopefully suppress any rust from forming in the future. So with the base done, the next thing to move on with the motor, and or the next thing to move on with was the motor, and wow, it was in quite a state. Um, After I eventually got the thing apart, it was very obvious that there had been water sitting in it for some time, and just like looking at the condition, you could see the actual rotor of the motor there. You could just see how much rust is on it and how corroded everything is, and you can see the terminal box there it was beyond saving. The terminals and the bolts that hold the wires on it just completely dissolved from the corrosion. But yeah, so the motor was completely seized up when I got it, so I had to use some force to actually get the core of the motor, the rotor, out of it. Um, so then once I had it out, I was able to I tested the windings. I wasn't expecting them to be perfect, but they measured perfectly fine. Equal resistance between each phase and everything, which was great news. So I dried out the motor as best as I could, just leaving it in the sun. Just so you can see there, it was good weather when I was doing that, leaving it in the sun and just letting as much moisture evaporate from it as possible. And then I put it back together, and the bearings were spinning, but they were making a lot of kind of growling and grumbling noises. So I knew I'd have to replace them at some stage. But I got it back together there, and you can just see in the right picture, I've actually, because there was nothing left of the terminal blocks, I had to kind of wire the motor in delta, just using a load of crocodile clips and jumper leads. Um, so that was just to actually see that was the motor going to run. And after hooking it up to my small inverter, it actually ran very, very well. It was surprisingly smooth, but you could hear that the bearings definitely had some wear in them, probably from the corrosion and having eaten away at the races in the bearing. Just taking a quick look at the motor plate as well, the badge, we can see it's a 3.7 kilowatt motor, 7.2 amps of running current, and 415 volts. And what's interesting about this, and also it's a Brook Crompton motor, so they're Brook Crompton motor. They're a very, very good motor. They've been around for a long time. They still are around actually. I think they moved overseas, but that was when Hawker Siddeley used to own Brook Crompton, so it's pretty cool to have that little logo on there. But what's interesting about this one is the rating of it. It says rating is S3 at 15%, which is that's an intermittent duty cycle, which makes sense for these sirens. They're not supposed to be run all the time, but it's surprisingly low. That means S3 15% means you're allowed. It's supposed to be 15% on time and then 85% off time. So if you're on for 1.5 minutes, you have to let it cool for 8.5 minutes, or 3 minutes on, 17 minutes off, and so on. And I suppose the reason for that is unlike a lot of these AC induction motors have a fan on one end, this doesn't. It's a dual shaft motor, so it's just purely relying on convection to wick the heat away using its fins. So I suppose that's why it can only stay on for so long. And you can see there, it's Class F insulation, and they allow up to an 80-degree rise during operation, so they're expecting it to get quite hot. So the next job with the motor was the four mounting screws that actually hold the remnants of those brackets onto the bottom of it. I had to get those out, and you can see there in the left picture one of the screw heads, just how badly corroded it actually is. So what I did with three of those was I cut a slot in them with the angle grinder, using a cutting disc, a thin one. Cut a slot in it, and believe it or not, they actually came out. They screwed right out, which I was very surprised with. And of course, it was the last one. It's always the last one, but it was completely stuck. You can see it there on the right. So what I ended up doing is I ended up taking it down to the workshop, take it down to a workshop I have access to, and welding a nut onto it. Um, so that not only did that put an immense amount of heat into the actual bolt itself, so that would help loosen up any corrosion, but it allowed me to get a spanner on it and slowly work it back and forth and actually get it out. So once they are out, I was ready to replace the bearings. So motor came apart again, and thankfully I was able to read the writing that was on the original bearings. You can see one there in the left picture. That's one of the bearings with the covers removed. So they normally have metal shields on them to keep the grease inside. And the bearings weren't terrible, but just the fact that there was corrosion on them, I just decided to replace them anyway. And thankfully, SKF still make the exact same bearing. So it's a SKF 6206 2ZC3 bearing, so a shielded bearing with C3 tolerance. So a bit you have a bit more tolerance there to allow for the motor to heat up. And so I got two genuine SKF bearings. They weren't that expensive. I think it was €25 for the two of them, which that was. I mean, while you're in there, you may as well change them. So I replaced those, took the old ones off with a bearing puller, and then pressed these new ones on. And then I also noticed when I put the motor back together, it was spinning surprisingly freely, which was a good sign. It means the bearings were good. But I that told me that the shaft seals on the motor weren't pressing against the shaft anymore. The rubber must have hardened, which makes sense after all this time. So I removed the old shaft seals from each side of the end bell, and I replaced them with two new ones. There was probably no reason to do this because the Siren probably won't be spending too much time outside, but just in case it ever is, it's nice to have it watertight again, get that IP55 uh, rating back. So once the new bearings were on the rotor and the seals were fitted, while I had the motor apart, since I knew that there was water in it at some stage, I decided to dry it properly. So as I said, because it has Class F insulation, it can technically go up to, I think it's around 105 degrees of running winding temperature. I might be wrong with that, but I think it's roughly around that. So I put it into an oven at 60 degrees, just keep it safe. But 60 degrees for several hours, and that will allow any moisture trapped in the windings just to escape. Just in case in the future it ever causes an arc, um, the drying it out really helps with that. And then once it was dried out, I sealed it up with some CRC urethane varnish. So it's actually a varnish, an insulating varnish made specifically for motor windings, made by CRC. So that's what that red coating is there on the right hand side. You can see it. That's the CRC varnish sprayed on the windings. You can also see the new bearing fitted to the shaft there. There's one on the other side, of course, as well, and that's what they look like with the covers fitted. Um, so after that, I was able to reassemble the motor. So you can see it there now. It's back together. I of course used some etch primer on the aluminium parts of it because once again you have to use etch primer with aluminium because aluminium when you strip it of all paint and stuff like that, it very quickly forms an inert oxide layer, which ordinary paint or primer won't stick to. You need to use an etch primer so that it actually nearly dissolves that oxide layer and bonds to the aluminium itself. So once that was on, then I could give it a coat of Rust-Oleum Duck Egg Blue, and this was just kind of a rough coat with a brush, just to kind of push it into all the crevices, just to make sure it really stuck. And then on the right hand side, you can see a new orange ceramic terminal block has been fitted because the original one that we saw a few slides previous was completely destroyed. There was no saving it, so it wasn't expensive. Just replaced it. Uh, had to drill out the two screws there. Well, it was actually I think there was only one screw holding it in, or one bolt, and then I think some sort of like a locating pin. But I just ended up drilling the bolt out and putting two new bolts in to hold it in place, so that's secure now. And the leads going into the motor were fine, so I just crimped new what would you call them, ring connectors onto the end of those. So that was perfect. Motor was basically done. Next job then, the stators. So as you saw a few slides back, just how warped and deformed the that surface, the rear surface of the stators was from the corrosion. What I did to fix that was I put it on a very thick piece of steel. I have a kind of a bit of a steel working surface out the back, and it's 15 or so millimeters thick, so good solid piece of steel. So I put it on that, and then basically just hammered it straight with a rubber mallet. It's important to use a rubber mallet here because if you use a steel hammer or something like that, you'll ruin the aluminium even more. It'll mark it. It'll deform it again. So rubber mallet just helps flatten it out, and just take your time because you don't want to move the aluminium too much or it might crack. But thankfully it all went back into place, and you can see it there. It's looking a lot flatter. On the right hand side, that's my poor attempt of color matching there. You can see I put some sky blue spray paint on it, and then of course realized it was completely wrong color. But this was before I found the Rust-Oleum duck egg blue. So thankfully the corrosion wasn't bad enough where I had to drill new holes. The originals were, there was still at least 6 or so millimeters of material left around the original, so that should be okay. Next stage with that then was to use a aluminium reinforced body filler. So I think I got one. I think it's Isofon metal repair, and I just basically slapped a load of that over it, making sure to degrease the aluminium first to make sure it has the best chance of bonding with it. So covered it with that, waited for it to go off, and then sanded it flat, so you get a nice smooth finish. That picture on the left there, it still looks a bit rough, but I actually went over it one more time again with a kind of a skim coat of the metal repair, before finally getting the primer on it. So then, as you can see here on the left hand side, that's after a coat of the etch primer was used. Once again, these are aluminium, so etch primer. So once that was dry, I was then able to put a coat of Rust-Oleum duck egg blue onto the stators, and you can see there that it's looking quite well. So obviously I did that for the 10 and the 12 port side, both sides. Next job then was the rotors. So as I said, I got very very lucky with these. They were already loose on the shaft, having probably been pushed off by the bulging stators. So once I cut away the remnants of the two nuts on the shaft, um, I was able to just pull them off, so that was fine. And you can just see how large these things are. I just for fun, I put one of the rotors from the 3D printed Gents model that I did a video about a while back. Just put it on top of it for scale. You could just see like just how massive these things are, and they're heavy as well. Like they have some serious inertia when they're rotating. I'd say it's just crazy the scale. Um, and you can see there I started sanding them. I used the sander for the top surface and the bottom surface, but I soon realized that wasn't going to work for the inside because there's so much there's like there's the curves and shapes of the blades. So I ended up just using paint stripper then for the whole thing, which completely removed everything, thankfully. I had to use a couple of goes of paint stripper to remove the original primer because it was quite tough after all these years still. So that got me down to bare aluminium. So then etch primer, you can see there on the left, you can just see the bottom half. The whole thing's been primered, but just I'd sprayed the top there. And another interesting thing you can see is the balancing holes that have been drilled. Or not, they're not holes. They're just material has been removed with something like a like a Forstner bit, or but for metal, and that's how they balanced it from the factory. So obviously it was heavier on one side, so they removed that material, and that's what helps to balance the rotor. Finally, then once they were all primed up, the red top coat could be applied. You could see on the left or on the right hand side there, that they turned out quite well. So that's a slight. It's not a high gloss top coat. I didn't want them looking too glossy because I don't think the original color was or paint type was gloss. So I just kind of chose a bit of a satin color, but they turned out quite well. Um, so that was basically all of the parts done. So I was able to then reassemble the Siren for the most part and just give it a test run because obviously I'd hammered the stators flat with the rubber mallet, but they were only flat to my eye, so I wanted to make sure that they actually were truly flat. And if they weren't, the rotors would have just rubbed against the stator and it would have locked the whole thing up. They'd have been hitting off each other because there's a tiny tolerance. It's around a millimeter the whole way around between the rotor and the stator. Tiny stuff for the size of it. So once I got it back together, I just gave it a low speed run on the inverter, and the parts didn't contact each other at all. So I got lucky with that. It ran very very smoothly on the new bearings, and you can see there on the right all the parts just laid out. I also took the elements off the heater plates, sanded them down, primed them, and then also painted them silver as well. I believe they originally, when they came to me, they looked like they had some sort of silver paint on them, so I just put something similar back onto them, and then re-riveted the heating elements back on. And you can see there on the left, I got a sticker made up with the nameplate, the Castle Castings Limited nameplate. What I did to make that, I just found a picture online. Forgotten which one it was now, but I imported that into SolidWorks, sketched around each letter because I couldn't find the exact font, and then I was able to extrude that and make a 3D model of the badge. Um, and then so I'll tell you why I made a 3D model for it in a second now, but I was able to then transfer the text onto a sticker and get those stickers made up. But I wasn't 100% happy with that because I know the original badge was riveted on, and the original badges also have a kind of, they look like they have a kind of a texture to them where the letters are physically there, they're not just printed onto a surface. So we'll come back to that in a minute now. Uh, One of the bigger issues was, of course, the brackets were gone that hold the Siren motor to the cast iron base. Mine were completely gone, and they were so far gone that I had nothing to go off really to draw them or to get new ones made. Um, so I started making a model in SolidWorks, just going off pictures online, but I knew that it wasn't going to be good enough to get an accurate model. So this is where this is where I have to say a huge thank you to Paul Lawrence over at the Attic Boy 11 YouTube channel. He was very kind of him. He went out to the garage and he measured up a set of brackets on one of his castle casting sirens down to the millimeter. It was brilliant. So I was able to then make a very accurate 3D model of the bracket. So thanks again, Paul. Wouldn't have been able to get these brackets done without you. So with the model made, I was then able to. I was going to make them up myself because, as I said, I have access to a workshop, a friend of mine, and I was going to make them myself. But I just did some googling online, and it turns out once you have a step model, there's a company called JLC PCB. They make circuit boards, but they've also expanded into 3D printing, and now they've expanded into sheet metal use. So I sent them the 3D model, and they were able to bend me up. They laser cut out and bent up the brackets there, as you see, from 4 millimeter thick mild steel. They also, I think they do stainless as well, but the originals were mild steel, so I kept them as mild steel. They bent it up and they shipped the two of them over to me, so that was very handy, and they were made very accurately. Now, I'm not sponsored by JLC or anything, but just it's very handy if anyone wants to get stuff like this made, because you wouldn't make it yourself quite as accurate as CNC equipment would. So at least it's going to be right. So very happy with that. And as you can see there on the right hand side, they fit very well. Um, I used the just put the bolts in loosely to actually make sure they fit. And what you can see on the right there as well, as you can see, the motor badge is looking very shiny all of a sudden. And what I did there is I redrew the badge, taking the information that was on the one I had and just drawing it in basically. And then I got a sticker, a heavy duty sticker made up, and I actually stuck it over the original badge and then popped the rivets through that. So what's nice about that is the original badge is still underneath, but just it looks a hell of a lot better than the faded one from the previous slides. Um, and that's when I decided. I was like, right, the badge or the sticker on the left, the castle casting ones, just isn't really going to cut it. So what I did then is, while I was ordering those brackets, I also, as I had the 3D printed or the 3D model for the badge, I sent that off and to JLC, and they printed them on a resin printer, which is much more accurate than the type that I normally use. What I use is an FDM printer, which just takes plastic filament and extrudes it out. But when it comes to getting very fine detail like letters and stuff, it just doesn't cut it. So they printed them out. That was perfect. And what I did then is, once I got the badges, they were completely black, so you couldn't really see anything on them. But what I did is I just sprayed over them with a good bit of white spray paint. As you can see, I basically flooded them with it, waited for them to dry overnight, and then I just took the top layer off with the sander and gave it a bit of a polish up. I didn't actually polish them in that picture on the right there, but I gave them a little bit of a polish with very very fine steel wool, and they came up. Look, I couldn't be happy with them. They turned out great, and I was able to pop rivet them to the cover on the motor. So then, with all these parts there, I was able to assemble most of the siren, and then once it was assembled, I just gave it another final coat, spray painted it with the duck egg blue while it was all together, just so that it would be a bit more seamless, covering up some or any gaps that might be there. And then finally, I put the badges on. And you can see the badges there in the picture on the right. They look I think they look very very good. Um, the paint really brought the Siren along. It's looking a lot better than it was before anyway. Um, so and then yeah, as I said, I attached the that new badge with pop rivets. So I think the originals were held on with pop rivets as well. So just it looks fairly good. And then that finally brings us to the finished Siren. So here it is in all of its glory. So and actually I didn't mention as well the Siren was missing its terminal box cover as well. So that's actually 3D printed out of plastic and painted up as well. So it is plastic for the moment. Of course, the original was metal. So now that that fits, I'll probably get it 3D printed out of metal. It's not too expensive, but for now it looks grand, and you can see the badges there. They really stand out. And what I did there is I also installed new their little round conduit boxes, galvanized conduit boxes on the ends of the heating elements, just because the originals, as I said, they were so far gone, they were barely recognizable. So it was a good bit of work, but I really enjoyed every bit of doing it up now. So as I said, I've done some low speed runs, but I'm just waiting now on a more powerful inverter. You see, because I can't run that on 230 volts three phase. I need an inverter that takes 230 volts and steps it up to 380 three phase. So I have one of them on the way, and I think it's a 4 or 5 kilowatt one, so it should be plenty for this. But I will be releasing a YouTube short just showing the speed. I think I got it up to about 20 hertz. It's currently in a kind of a garden tunnel, so all the sounds reflected back on me. So it's loud as it is in there, even with earmuffs on. But yeah, I really hope you enjoyed the process, and stay tuned because I also, as I said, I have been taking this model apart and I measured each part, and I've been making a 3D model of this Siren as well. So I'll be able to make a miniature version of that, and hopefully we can get that going, make a few YouTube videos on that as well, and maybe even get some shutters on it. Because now that I have a real Siren to measure off, it's very handy. I could just go outside and get whatever measurement I need to make it as good as I can. But I hope you enjoyed the video. Thanks very much for watching, and I'll see you soon.